Pre-calc honors. All right, let's start 9.3. The complex plane and De Moivre's theorem. First definition is this here, complex plane, but can you also add an complex number? Okay. All right. So the definition is a complex number such as z equals x plus yi, or if you see z equals a plus bi, they're exactly the same, okay? Where, remember in algebra 2, I is the square root of -1, and x and y, or if we use, or, and how about this, or if we use a and b, or a and b, okay, are real numbers. So let's kind of graph it out a little bit. So in the complex plane, remember we have the Cartesian plane, aka rectangular, then we have the polar grid. Now this is a complex plane. So we have real numbers axis over here. Okay, then over here, up here on the y-axis, we have the imaginary number axis. Okay, so we have real axis and imaginary. So i.e., let's make up something really quickly. We have 5 minus 3i. So how would we graph that? This is just a dot. Okay, so this is a dot. So we're going to go 5 unit, that's a real number. So think of it as a plus bi, or think of it as x plus yi. Okay, so we have 5, 1, 2, 3, 4, 5. That's 5 real numbers, right? 5 to the x-axis, so that's positive, goes right. Then we have 1, 2, 3, so -3. So here we go. So this right here is 5 minus 3i, so that's your dot. Now, whenever you see this, z equals -2 minus 4i, or z equals positive 10 plus 100i, it doesn't really matter. So if you see this, it is something like this. So we are still going on the real axis, a -2, then we'll go down 4. So we'll do this one. So this is your z. So this is your z, okay? Just like that. So that's your z. Or you can write z equals -2 minus 4i, just like that. Or you can just use a z. Now, as you know already, back in whenever you first start learning absolute value. So an absolute value would denote the distance. So this right here, an absolute value of z, would denote the distance of that equation, okay? Magnitude or modulus. Should have just had the columns over there. So let z equals x plus yi be a complex number. The magnitude or modulus of z denoted by an absolute value of z. Okay, so now the magnitude is the absolute value of z, is defined as the distance from the origin to the point x comma y. So the absolute value of z, if we were to look for the distance, we would use the distance formula, right? And the distance formula would be the square root of x2 minus x1. But what if x2 is just x, and x1 is the origin, and we square that, then add y2 minus y1. Well, y2 is just y1 is at the origin, so we can just say something like this. Now, to simplify this further, would you agree then the absolute value of z, which is the distance, is simply the square root of x squared plus y squared, if we have the point from the origin? Well, have we not seen this formula somewhere? The square root of x squared plus y squared. Isn't this the same as the radius formula if you were given an ordered pair in rectangular form and you were trying to find the radius? I know, right? They're totally related. All of these are related to each other. The absolute value of z. So as you can see here, this is another way to say the magnitude. So absolute value of z is the magnitude. Okay, and as you know, we use this to represent the magnitude. Since since z equals x plus yi, then the conjugate okay. So in your book, we use the z with the bar on the top to represent the conjugate, and the conjugate is when we change the sign right in the middle, just like that. So the conjugate equals x minus yi. So what if we multiply the conjugate pair together? So that means we want to multiply z to z bar, which leads us to an equation x plus yi times x minus yi, which equals to x squared. Technically, this is minus y squared I squared, but I squared is -1. So this is really x squared plus y squared. Well, that equals to z times z conjugate, but if we are thinking about, okay, so this equals to z times z conjugate, so think of this equation for me. Well, but would you agree if we're looking for the distance of z, okay, if this is the distance of z, would you agree then, I'm going to go one step further, z and z conjugate will have the same exact distance. So if we are talking about distance, they are identical. So technically we can write z squared, which equals to x squared plus y squared. But what if we want to take the square root? Well, would you agree then that the square root gives us back to z equals the square root of x squared y squared? Now, this is just one more way to look at how we come up with the formula for the distance, aka, think about it, the magnitude, aka it's the same formula for the radius, okay? Next definition says polar form. So if the radius is bigger than or equal to 0 class, and theta is in between 0 and 2 pi, inclusive at 0. The complex number z equals x plus yi is z equals, as you know already, x in polar form is radius times cosine of theta, and y in polar form is radius times sine of theta, and then we stick an I, imaginary number, at the end. But we can make this prettier by factoring out the radius. So z equals radius cosine of theta plus, and then we stick an I in the front here, I sine of theta. So I do want to highlight that formula. Okay, so highlight this formula. This right here, guys, is the polar form of complex number. And again, be mindful of those restrictions, okay? So theta has to be a positive first revolution and radius got to be negative. Okay, so we got some theorems going on here. Let z1 equals radius sub 1 times cosine of theta sub 1 plus I times sine of theta sub 1. That is the polar form of complex number. And z sub 2 equals r sub 2 times cosine of theta sub 2 plus I sine theta sub 2. Be two complex numbers. Then, when we multiply the two complex numbers, all we're doing is really adding the angles together and then multiply the radii together. Now, if z sub 2 is not going to equal to 0, because when you divide, you can't have a denominator equal to 0, then we can divide them. Well, dividing them is very similar. Then we divide the radii and then subtract the angles, which you do need to know these formulas, okay? Last definition, De Moivre's theorem. If z equals radius times cosine of theta plus I sine of theta, this is just the polar equation for complex, is a complex number, then z to the nth power equals r to the nth power times cosine n times theta, close that up, plus I times sine of n times theta. Now, this makes a lot of sense because when we were multiplying just two z's, what did we multiply? Three z's, right? Then would you agree, especially if the z's are identical, so if we multiply three z's, then we would just take three radii and multiply them, and we would add up all the angles. But if the z's are identical, then we're just going to raise them to the power of n. Now, what is n? N can be any integers, that means whole numbers, so 1, 2, 3, 4, 5, okay? And n has to be bigger than or equal to 1. Example 1. Plot each complex in the complex plane and write it in polar form. Express the arguments in degrees. So this one, they do not want us to use radians, okay? So complex polar form, remember the restriction. Radius is got to be, do you guys remember what the restriction for radius for complex form? Has to be bigger than or equal to 0. And since we are in degrees, theta has to be at least 0 degrees and all the way to 360. So that has to, we have to follow that restriction if we are writing in polar form. All right, first things first, let's write down the formula. Okay. Oh, let's plot first. Duh. Okay, so plot, let's call it A. Okay. A, we are going to plot. Make sure we write real number axis here, and this is the imaginary axis. Axis, I meant. Radical 3 is in between 1 and 2, and we have 1 I. So just like that. So that's it. Okay. Now we will make a line here because that's a z equals. Now guys, if you just have a dot, I'm okay with that too. No worries, okay? Then over here, let's go and do part A over here as well. Let's graph both of them at the same time. I now have, let's see, we will have, I need 9 times rad 3. Okay, that's a lot of positive x-axis, and I need negative 9y. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is your imaginary axis, and this is our real axis. Okay, so technically this is a dot, but again, it's not really important that if you give me a dot or not a dot. Okay, I'm not really strict on if you give me a dot or a segment. No big deal. So 9 rad 3, let's see. I'm probably going to rescale my x-axis. So I'm going to rescale it, guys, by 2, 4, 6, 8, 10, 12, 14. I'm going to extend it a little bit longer. 14 and 16. The reason I'm rescaling it is because 9 rad 3 is about in between 15 and 16. So I need this much like that. Okay, I'm not going to rescale the y because I did make 9 tick marks. So this is really technically your dot of 9 radical 3 take away 9i. Now in your book, it may connect this to the origin. That's okay too. Okay, so you can connect it or you don't have to. It's not a big deal. As long as you have a dot, then I'm good. If you have a dot and a segment, cool. If you just have a dot, also okay. Then part B says, now write it in polar form. So let's go and do part B. How about if I use a different color for part B? Cool, okay. So part B, we would have the polar form z equals radius cosine of your angle plus I sine of your angle. Radius got to be positive, so let's find the radius. Radius is the distance of z, which is the magnitude of z, which is the formula of x squared plus y squared. Okay, x is going to be radical 3. So radical 3 squared is 3. Y is up 1, so that's just going to give us 1 in there. That's going to be square root of 4, will give us a radius of 2, and that's definitely positive, so we are okay with the restriction of radius. Then we need to find theta. Theta is formula sets tangent inverse of y divided by x. Now remember, if it's in quad 2 and quad 3, then we have to go and add pi, or in this case 180. But because it's in quad 1, we don't have to worry about it. So tangent inverse of, again, your y value is 1, so 1 divided by rad 3, which is an angle that we do know perfectly. This is 30 degrees. Well, check, right? Positive angle, positive radius. We're going to use those to put our z equation together. So z equals radius is 2. Cosine of 30 degrees plus I sine of 30 degrees, and box that up. Not too bad, right? Okay, let's do this again and over here. If you don't have enough space, try to squeeze that in. Similarly, the polar form is z equals radius times cosine of theta plus I times sine of theta, and we have to follow the restriction of radius and theta. They both have to be positive. So radius is the magnitude of z, which is going to be the square root of x squared plus y squared, which is x happened to be 9 radical 3, and I square that, so that's going to be 81 times 3. Then plus, okay, y is negative 9, and I want to square that, so that's going to be 81 times 3, and then plus 81. So under the radical, I have 324. So that's right now. I'm going to leave that right there. I don't want to do anything yet. Actually, let's go up. Let's simplify, because that's a perfect number. I just want to make my square root a little bit. That's 18. All right, so let's leave. Now we can leave 18. Then let's find theta equals tangent inverse of y divided by x. We are in quad 4, so if we are using the calculator, it will give us a negative degree, but the restriction for polar said we have to be positive, so make sure you guys add a full revolution, okay? So tangent inverse of y value is negative 9, x is 9 rad 3. Let's reduce that. That means theta equals tangent inverse of 1 over negative rad 3, which will give us a negative 30 degrees. And you can test that out using your calculator. But remember, restriction sets, we cannot have a negative angle for polar form. So we will now go and add, because from here to here is negative 30 degrees. So what we're trying to do is go this way, okay? So we can add 360 degrees, or you can take 360 minus 30, which is exactly the same thing. That will give us 330 degrees. So now we have enough to write. So that's going to be 18 cosine of 330 degrees plus I sine 330 degrees. Box that up. And again, in polar form, radius and degree must be positive. Okay, y'all? Hey, awesome kids. All right, so this recording, it's for 9-3. Okay, we will start with example 2. In example 2, the directions is write each complex number in rectangular form. So in rectangular form, what we will do is then it's gonna be a lot easier than what you think. So first, we will write the 3 down because that's the radius. Cosine of 210. 210 is in quadrant number 3. So cosine in quad 3 is going to be negative radical 3 all over 2. And then we're going to drop down your I, okay? Sine of 210 in quad 3 is a negative 1 over 2. What do we do from here? Remember, rectangular form, okay? It's going to be x plus yi, okay? So from here, we can just distribute, and then that's it. So when we distribute the 3, it's negative 3 rad 3 all over 2. And I'm going to multiply the 3 to the negative 1/2. So this is going to be a negative 3 all over 2, and I'm going to put the I behind it. And this is the final answer. In complex form, I'm sorry, it's already in complex and in polar form. Now this is complex rectangular. So now one of the questions is like, hey, do you want me to put it all over that common denominator of 2? No, don't do that, because in complex form, we always write it as x plus yi. Okay, so this is going to be your x right here, okay, and this is going to be your y. Okay, your y is negative 3 over 2, and your x is a negative 3 rad 3 all over 2. Okay, so don't put them over one common denominator. Next, we are going to try B. B, we are going to do the same thing. Okay, we're going to write 4 down. But I'm going to be stuck. I do not know what cosine of pi over 10 is. So I'm going to bust out my calculator. You know, hopefully you trust me. Pi over 10 looks like that's in radians. So I'm going to change my calculator, double check my calculator, make sure I'm in radians. Okay, so cosine of, and if you have a calculator ready, I would love it if you can double check my work. So cosine of pi divided by 10, my trusty calculator says, I have it at about 0.95, okay, or 951. It doesn't say how to round, so you can round it as far as you want. So plus I times sine of pi divided by 10 in radians, it's 0.309. Okay, so if I did that 3 decimal places, how about if I add another one on the cosine, just to keep it the same. So what we are going to do now is we are going to distribute your 4, okay? In rectangular complex form, the radius isn't factored out, so we have to multiply it back. So when I multiply it by 4, since I already have this out, I'm going to multiply this first, okay? So 1.2, how about 1 point, since I'm rounding to 3 decimal places, I'm going to keep it consistent, okay? 1.236i, so that's that first one. Then I'm going to multiply 4 to my cosine of pi divided by 10. So this is going to give me a 3.804. So that's your x plus yi, and that's the final answer. Okay. Next, example 3. Find, you're giving z and w. Okay, so find when z multiplied to w and when z is divisible by w. Leave your answers in polar form. So A, it's already in polar form, so I don't have to do anything special except that we will multiply first. So in multiplication, okay, let me remind you of what we do when we multiply. When we are multiplying, we multiply the radius and we add the angles. Okay. When we divide the radius and we subtract the angles. So keep that in mind when we're working these out. So multiply first. So that means I'm going to take my 2 radii. So 4 times 2. Okay. Then I'm going to add my angle. So cosine of 3 pi over 8 plus 9 pi over 16. So that's the 2 angles adding together. Plus I times sine of 3 pi over 8 plus 9 pi over 16. And from here, I would just sit here and simplify. So let's work it out. If they give you radians in the original problem, then keep it as radians in the original problem, okay? So common denominator tells me that this is a 16. So this would turn into 6 pi. So 16 and 6 pi. So my final answer when I multiply is 8, okay? Then cosine 6 pi plus 9 pi is now what? So is that 15 pi over 16 pi? Okay, very good. Then plus I times sine of the same exact angle. Okay, so that is what we do when we multiply. Okay, so the formula seemed, when we were reading the formula in class, it sounded really scary, but when you are really working it out, it isn't that scary. Now, what do I do when we divide? So just like a minute ago, we will take the two radii and we divide them, okay? And we are now going to attempt to subtract your angles. So take the first angle, subtract the second angle, okay? So same thing on this side. First angle, 3 pi over 8, subtract 9 pi over 16. Yes, I would now need to go and find common denominator. Since we did the multiplication above, this one should stay the same, right? We're still at 6 pi. So here we go. All right, so when we divide z over w, final answer is 2 in the front. So now your radius is 2. 6 minus 9 pi over 16 is now cosine of negative 3 pi over 16. We will talk about that in just a second. Plus I sine of what you get on the first angle, you're going to get on the second angle. Okay, so here's the negative angle. Now in your book, it really doesn't like negative angles because I believe when we define this, it says that theta, radius always has to be positive and theta always has to be from 0 to 2 pi or 0 to 360, depending on if you're in degrees or not. So what we need to do is convert negative 3 pi to 16 in positive angles, okay? So final answer is z divided by w equals 2 times cosine of. Now how do I convert negative 3 pi over 16 to positive angle? What would you do? Let me draw it out for you so you have an idea what negative 3 pi over 16 is, okay? So here's a negative pi over 2. In common denominator of 16, this is really negative 8 pi over 16. So negative 3 is just right there, that very small amount, okay? Oops. So here's negative 3 pi over 16. Because we define it as a positive angle, here's what we need, okay? So would you agree that I can take my negative angle and add a positive 2 pi, okay? Positive 2 pi then leaves me to believe, let me get a different color pen really quick, that I can make a common denominator of 16. So if that's 32, okay, 32 pi. So negative 3 pi plus 32 pi, now you are at a positive 29 pi over 16. Okay. And that's how you convert all of that to positive angle. So now, with positive angles and positive radius, okay, the division of z divided by w is 2 times cosine 29 pi over 16 plus I times 29 over 16. So that is for that one. Now, what if they give you a problem, but that's not in polar form? Then guess what? You had to do a little bit more work, okay? I first had to convert it in polar form. So to convert it in polar form, I would need to find r and theta, okay? So let's find r for z. So for z, r is square root of x squared plus y squared, okay? X squared is 1. 1 squared is 1. Y is negative 1, but negative 1 squared, it's also 1. So radius is 2 for z. I'm sorry, rad 2. Then I also need to find theta. So theta for z is tangent inverse of y divided by x. Let's sketch out where z is. Okay, so I want to make sure if I need to add a pi or in degrees, 180 or not. X is positive, so I'm positive, and then z is going to be, I'm sorry, y is negative. So you're in quadrant 4. Okay, so theta in quad 4, I can totally handle that. Okay, y is -1, x is 1, so this is a multiple of 45 degrees. Okay, if you punch this in your calculator is going to give you a -45 degrees, but you can't have a -45 degrees because theta is restricted from 0 to 360. So I would now have to use 315 degrees. Okay, so that's theta, and that is r. So now let's put it in polar form for z. So z is square root of 2, okay, times cosine of 315 degrees plus I times sine of 315 degrees. No, we have not done multiplication yet. We're just converting to polar. I will now try to graph out w to see what quadrant that is in. X is positive, y is negative again. So again, I'm in quadrant number 4. The reason I do that is because I want to make sure if I need to add, when I'm looking at 180 degrees or not, when I'm looking for theta. So w equals, let's find radius, okay? So r equals square root of x squared plus y squared. X is 1, so 1 squared is 1. Y is negative rad 3. Negative rad 3 squared is 3. So this is going to give me square root of 4. Square root of 4 is 2. So the radius for w is 2. I will now attempt to find theta. Okay, so theta is always tangent inverse of y divided by x. So tangent inverse of y is negative rad 3, x is 1. We're in quad number 4. This, if you put in your calculator, okay, let me give you, it would totally give you a negative answer. Yes, it will give you a -60. But we can't have a negative angle for theta. So we're going to go the other way around. Oops. -60 is equivalent to 300 degrees in the positive rotation. So w equals 2 cosine of 300 degrees plus I sine of 300 degrees. Okay, so that's just what z and w converted to. So now I will attempt to find multiplication of z times w. To do that, I will multiply the radii. Okay, the radius with radii is really the correct term. So rad 2 times 2 is 2 rad 2. In multiplication, I will add my angles. So cosine of 315 plus 300 and plus I sine, same thing, 315 plus 300. Now because this problem did not start out in radians, so most of the time when it doesn't start out in radians, you can just put it in degrees, okay? But if it starts out in radians, and you keep it as radians. So final answer, when I combine these, it's going to be 2 rad 2, okay, times cosine of, okay, well, 315 plus 300 is now 615 degrees. And we are going to talk about, we can't keep that at 615. Sine of 615 over here as well. 615 is over a revolution, but theta, remember, theta was restricted to just the first revolution. So at 315, I can subtract it from a full revolution. Okay, so side work. 615 I meant, not 315. 615, okay, it's the angle we have. Take away a full revolution. So you should end up at 225? 255. Okay, there you go. So let me confirm really quickly. 615 minus 360. 225. Okay, so this is now at 255. I am sorry, 255. Okay, so 615. Okay, take away a revolution. It's the same location as 255 degrees. So that's what we would use instead of 615. And yes, you do have to bring it back to the first revolution, okay? So 255 degrees here as well. So that is the answer if we were to multiply them, okay? Now let's do division. Woohoo. Okay, so z divided by w equals, so z has a radius of radical 2, okay? W has a radius of 2. I will now try to subtract the angles. So cosine of 315, take away 300 is now just cosine of 15 degrees. If you have cosine of 15 degrees there, you will also have cosine of 15 degrees here. And I am done with my division problem. Now, if this is going too fast, please do pause it, okay? Next, we are now going to work out problem or example number 4. And did I tell you that if this is too fast, please do ask or just pause it, okay? Example 4. Oh, my formatting. How frustrating is this? Okay. Write each expression in standard form of a plus bi. So, well, okay. I have some space between there, so I guess we'll start down here, okay? So a plus bi is the same as just x plus yi, okay? So don't be stressed out if you see different variables. So radical 3, as you can see, okay, I want to make sure. So radical 3 times cosine of 15 pi all divided by 18 plus I sine 15 pi all over 18. Radical 3, 2 power of 1. It's still the power of 1, no big deal. Cosine of 5 pi over 18. This is not the one that you could do by hand or, by memory. So I'm going to punch it in. Ready? Cosine, let me see if I'm in radians. I am in radians. Perfect. Cosine of 5 pi divided by 18. This is giving me a 0.643 plus I. Okay, let me do this square bracket. I times sine of the same thing. So that's going to give me 0.766. So now I will try to distribute your rad 3. So here we go. So this is times radical 3. Since I already have this on my calculator, I will just write this first, 1.327i. So that's that one. I'm going to take my calculator to multiply. So let's see, rad 3 times cosine. Radical 3 times cosine of 5 pi divided by 18. And that gives me 1.113. 1.113. Okay, so that is the form of a plus bi, or you're used to seeing this, x plus yi. Either one, it's exactly the same. So we'll highlight this, and that's your final answer. You can box it up if you don't have a highlight handy. Okay, next, we have now raised to the power. So really, this is a true test of how do we use De Moivre's theorem. First, we have to put it in polar form, okay? So let's plot out 1 minus rad 5. So that's going to be in quadrant number 4. Let's find the radius. Radius is square root of x squared plus y squared. X is going to be 1. 1 squared is 1. Y is negative rad 5. Negative rad 5 squared is 5. So this is square root of 6. Let's find theta. Theta is tangent inverse of y divided by x, which is y is going to be negative rad 5 divided by x is 1. I don't have this memorized, so I would definitely have to use a calculator. So let's punch in my trusty calculator. Because this one is originally in rectangular form and you are now converting polar, so try to use degrees, okay? If it starts out in radians, keep it in radians, but because it's not, we're going to use degrees. So tangent inverse of negative radical 5 gives me a negative 65.9 degrees, okay? But you cannot have a negative angle, so keep that in mind, okay? So negative 65.9, okay, degrees. So what do we do with this? Okay, we are going to find an answer. Can you tell me what to do next? How do I get a positive angle for that? Can you tell me what to do from here? I can't use negative angles, so what would you do to get positive angle? Should you add a what? A 360? Sounds like a great idea. Okay, so add 360. So did we end up with 294.1? Okay, so 294.1. So negative 65.9 is the same location in the positive direction. Okay, so we're going to try to use a positive angle. So here we go. So you have this now in the positive angle. Radius is positive. Let's rewrite it. So instead of writing 1 minus rad 5I to the 8th, we're going to keep it in polar. Okay, so rad 6 is our radius. Cosine of 294.1 degrees plus I times sine of 294.1 degrees. So all of this is raised to the power of 8th. We haven't done that yet. So based on De Mor's theorem, we're going to take the radius and we're going to raise it to the power of 8th. Okay, then we are going to multiply 8 to each angle. So 8 times 294.1 degrees plus I times sine of 8 times 294.1 degrees. And I'm going to use my calculator. 294.1 degrees times 8 equals. All right, so this is going to give me some ginormous number. Here we go. Cosine of 2352.8 degrees. Okay, so I'll bring down the radius in just a second. Since I have this on my calculator, I don't want it to go to sleep, so I'm going to copy that down. So rad 6 to the 8th is actually the radicals are gone. So now that's just going to be 1296. So that's your radius. No, we're not going to keep it in polar. Okay, so we're going to convert it back to a plus bi. Okay, so a plus bi, it has to be, so what is cosine of that huge number? So this just maintains this 1296. Okay, cosine of this huge number is negative 90.975 plus what is sine of that number? Sine of 2352.8. 2352.8. Okay, and do double check my math. I want to make sure I'm going the right page here. So negative 0.222 if I'm rounding it to 2 decimal places. Okay. Okay, so here we are. This is what we have. So now I have to distribute. Okay, like that. So, oh, I forgot that I. There you go. So let's distribute 0.222 times times 1296. So 0.222 times 1296. This is giving me a negative 287. I'm just gonna round it to 2 decimal places, so that 0.71i. In the front, negative 0.975 times 1296 is negative 1263. Well, this one just gave me 1 decimal place, so perfect. So this is now my final answer in the format of a plus bi. And this is the end of our recording for today.